We talked about scalar and vector. Scalars, no direction. Vector has direction. Both of them have got magnitude. And what is the meaning of magnitude in physics? Magnitude in physics means that you use some number followed by the unit. You use some number followed by the unit. That is the meaning of magnitude in physics. So if you say 5 meters, then 5 is the number and meter is the unit. You can also say 5 centimeters, 5 angstrom. In all cases, there has to be a number and there has to be a unit. That's how we talk about magnitude for any physical quantity, whether it is scalar or vector. Now, after talking about scalar and vector, distance and displacement, now we should talk about speed, velocity, and acceleration. Let me first define the meaning of uniform motion. We will be talking about just one direction. So just focus on one direction. That's it, straight line. Uniform motion means that in same time, distance covered is same. In same time, distance covered is same. Say 1 minute, let's say 1 minute. 1 minute time we look for, and we are looking at some particle moving. 1 minute time. In 1 minute, suppose it travels 4 meters. Next 1 minute, again say 4 meters. Next 1 minute, again 4 meters. Next 1 minute, again 4 meters. In same time, it is traveling same distance, not more, not less. Then we say it is uniform motion. In practical world, that may not be the case. When a car starts, then starts from rest. It was parked, let's say, somewhere and starts. So initially it will travel slowly. So initial 1 minute, if you look for, then the distance covered by it will be small. But it picks up speed, and next 1 minute if you see, unless there is some traffic, next 1 minute if you see, it would travel larger distance. And assuming nobody comes in between, there is no narrow lane, it will pick up speed more and more and more. I will talk about speed, the definition later, but I hope you understand the meaning of speed. It is a very common word. So in the same time, it will be traveling larger and larger and larger distance. So that is not uniform motion. Practical world is actually generally more complicated when we talk about motion. There are so many turns also in real life situation, and as I said earlier, we are focusing at the moment about just straight line. How different real life is, you know that. You go to any market and I don't think you'll be going absolutely straight. Little bit of turning is there in practical world, no matter how simple the path is. Anyway, so when we talk about uniform motion, it means that in same time, the distance covered is same. Any questions up to this point? Let me know. Well, so I suppose no questions. All right. So let's now define what do we mean by average speed. Average speed. What you see in the speedometer reading, any car, any motorbike, all of them have got speedometers. Also they have got odometer, but let's talk about speedometer. Speedometer tells the speed at that very moment. At that very moment. But I'm not talking about instantaneous speed right now. Speed at that very moment is called instantaneous speed. Generally, dealing with instantaneous speed is more difficult, and I don't think that is in your scope also. Average speed is in your scope. Average speed. Instantaneous speed requires calculus. What is average speed? Average speed is something very easy to handle. You go to one place, you come back. What is the total distance you traveled? Total distance. All turns you can add. And if you're talking about straight line, then add all straight distance you have covered. Total distance, simply. Divide that total distance by the total time of the journey. Total distance divided by total time. That is the definition of average speed. Total distance divided by total time. Right? That is average speed. Sometimes it may not be very useful. Sometimes it may not be very useful. For example, you are in your school bus, and suppose your school is quite far away and you face traffic in the route. Sometimes your school bus will stop when there's a red light, and if there's a wide open road, it may be going quite fast. So when you reach your school and you say my average speed was so and so, fine. You will say total distance divided, you will divide that by total time. But that information will not tell how many times bus stopped. It had zero speed. How many times did it have zero speed? How many times it was just standing, whether waiting for red light to turn yellow, green, etc. Or somebody came in front and brake had to be applied. That average speed information will not tell what was the greatest speed that the bus could have in some open, nice, broad path and road. that information also will not be there when you just say that the average speed for my journey was so and so. So the concept of average speed has limitations. It has got some advantages also. It gives an overall picture. Just a broad picture it gives, right? So average speed is total distance divided by total time. As I said earlier, in physics, magnitude of something is told by a number followed by the unit. In physics, there are some fundamental units. For example, meter, kilogram, second. Meter tells the distance, kilogram tells the mass, second tells the time. Yes, you can also say, why not kilometer? For distance, yes, kilometer also tells the distance. Let us say it is meter for distance, kilogram for mass, and second for time. There are fundamental units, and then there are derived units. Derived units are those that you can get from the fundamental units. Say for example, I'm talking about speed. Now speed is a physical quantity. It is distance total upon time. What is the unit for distance?
Meter.
Meter. What is it
Second.
for time? Yes. And it for time? Second. Yes. So divide the units. Divide the units. Just the way you define a physical quantity, just the way you define a physical quantity, in the same way you can get its units also. That's something which makes it easy. So I don't have to give a third name for unit for speed, average speed. I would just say meter per second. Meter per second. Yes, you can also say kilometer per hour. Distance, kilometers, time, hours. So kilometers per hour. In fact, there are more derived units. There are more derived units than there are fundamental units. Most of the units are derived. So there are just a few fundamental units. All other units you are able to get from those fundamental units. Units are like numbers. You can cut them. So if you want to convert kilometer to meters, it's all very easy. Kilometer and kilometer you can cut. Meter and meter you can cut. So numbers you can cut. Units also you can cut. Alright, I was talking about average speed. Total distance divided by total time for a particular journey. That would be the average speed for that journey. Unit is, say, kilometer per hour or meter per second. Suppose I give you one problem to try. Consider some particle. It travels for 6 seconds. It travels for 6 seconds in total. For first 4 seconds, it travels 16 meter. For first 4 seconds, it travels 16 meters, and next 2 seconds again 16 meters. That means it picked up speed so much that in the next 2 seconds, it covered the same distance that it covered in first 4 seconds. So what is the average speed for this whole 6 second journey? So what will be your answer? Your answer will be average speed is total distance divided by total time. So how much is the total distance? 16 in the first 4 seconds. 16.
32.
32. 32. So anybody using non-headsets, please switch over to headset. First 4 seconds, 16. Next 2 seconds, 16. The total distance is 16 plus 16.
30.
That is 32.
32.
What is the total time interval?
6
Total
seconds.
time interval? 6 seconds. Now, write average equal to 32 divided by 6. 32 meters
5.3
divided by 6 seconds. When you divide that, you should be getting 5.33. 5.33. But what is the unit?
meter per second.
Meter per second. So 5.33 meter per second. Any questions? Let me know. Fine. Let's talk about velocity. Velocity. Velocity is a vector. Speed is not a vector. Velocity is a vector. Velocity will tell you the direction of motion also. So when you say my average speed for the journey was so and so, nobody is concerned with the direction when you're talking about speed. But when you say my velocity was so and so, when you say my velocity was 5.33 meter per second, that's not a complete answer. Velocity must also tell the direction. So how do we define average velocity? Again, as I said earlier, one can talk about instantaneous velocity also. Instantaneous means at that very moment. But we'll be talking about average. Average velocity is defined as displacement, total displacement divided by total time. Total displacement divided by total time. That's the definition for average velocity. So suppose something travels in this way, if something travels in this way, from A to B, then the displacement is this. So that's the displacement. Right? The path does not matter here. How the thing has gone from A to B, that does not matter. Because displacement means straight line. Whether path is this or path is something completely different. You have to join initial and final points, that's it, irrespective of the actual path covered. So that straight line that I have joined, that you have to divide by time. And you have got average velocities magnitude. Now, what is the direction of average velocity? Direction of average velocity is along displacement. Along displacement. So in this figure, AB vector, that arrow that you are seeing, that vector which is telling you the direction for displacement, the same vector would tell you the direction for average velocity. That's it. Any questions about average velocity? If you have, then let me know. Some questions?
Sir, distance traveled.
Sir, the distance, total distance we have covered. Total distance we have covered.
Yes. So distance basically.
Sir, if distance is equal to the
Sir,
displacement.
if the object is going in a straight line without reversing its direction.
When the object is going in one direction, in very simple language, when distance is equal to magnitude of displacement. This is how we represent magnitude in case of a vector. When distance is equal to the magnitude of displacement, then this is what happens. This is a very short answer. Practically speaking, or giving an example, if it is a curved path, it can never happen. If it's a curved path, then distance will always be more than the magnitude of displacement. Any curved path you take, distance is going to be more than the magnitude of displacement. So, example wise, we would say that when it is a straight line motion without taking any turn. In straight line, if you take turn, that is also a problem. Imagine somebody going like this, then taking a turn and finally settling maybe here. So the person goes to B but doesn't stop there, takes a turn and goes C, and that's where the person stops. So displacement wise, it will be A to C only. Magnitude of displacement will be AC, and distance will be AB plus BC. So distance becomes more than the magnitude of displacement. So the rule is that there should be no curve, no curvature, and there should be no turning back. Then you can have distance equal to magnitude of displacement, and then these two fellows will also become equal. Any questions? Let me know. All right. Now before you try this question, let me talk about uniform motion for a moment. I said that let's focus on motion on a straight line, and then we say if equal distance is covered in equal time, then that is uniform motion. Then I also talked about average speed. Average speed, talking about average speed makes sense when you have got non-uniform motion. Sometimes your speed is more, sometimes your speed is less. I'm talking about instantaneous speed. Sometimes your instantaneous speed is more, sometimes it is less. So it is meaningful to talk about average speed. But if it is uniform motion and your speed is not changing at all, your instantaneous speed is not changing at all, then why bother? Then we say simply speed is equal to distance upon time, and that speed is the constant speed, right? So average speed is just like the true speed in case of uniform motion. So if you have uniform motion, you will just say speed equal to distance upon time. No need to call it average speed. It is the true speed, or it is the instantaneous speed, which is distance upon time. It is going to be same for the whole journey. But if it is not same, if the instantaneous speed is not same for the whole journey, sometimes it is zero, braking, sometimes it is very high, then it is sensible to talk about average speed and use the word average. So for uniform motion, you can just say speed equal to distance upon time. And for a non-uniform motion, you will say average speed equal to distance upon time. Any clarifications, questions? Let me know. So how about some practical examples of constant speed? Some practical examples. One practical example is speed of light. 3 into 10 to the power 8. That exp means exponential. It is 10 to the power 8. So that is fixed. Light comes from sun to earth. No matter how much distance it travels, every instant it has got the same speed. 3 into 10 to the power 8 meter per second. So why in such a case talk about average speed? It is not becoming more, it is not becoming less, it is just flat. 3 into 10 to the power 8 meter per second. Another practical example is speed of sound under the given conditions. Under the given conditions, speed of sound is fixed. So when you talk, speed of sound is fixed. It's not more sometime, it's not less sometime. So why talk about average speed of sound under given conditions? So whenever you deal with situations in which speed is fixed, things really become easy. Speed equal to distance upon time. This problem is based on speed equal to distance upon time.
Sir, 9 into 10 to the power of 10 meters.
Nine into 10
9 into 10 to the power of 10 plus.
10 meter per second. 10 meter per second.
No, 10 to the power of 10 meters.
10 to the power of 10, yeah. Meter, not milliseconds.
So in such a case, you will just use speed equal to distance upon time. So distance equal to speed into time. Earlier I was telling you that you can cut unit like number. I will illustrate you that here. It is a very good practice if you do it right now at this stage. Write unit for everybody. You can't cut minute with second. Convert minute to second. Now, second gone. Only meter is left. Unit will automatically come. The unit for the final answer will automatically come. And if you have any questions, then let me know. So I suppose no problem. Okay.
Sir, 50 kilometers per hour.
50 kmph. How did you do it? Method?
So the distance traveled is 2400 kilometers minus 2000 kilometers, which is 400
Okay.
kilometers. And then the speed is distance by time. So 400 by 8, which is equal to 450. And km divided by r.
So 50 kmph. Any questions? Let me know.
Is equal to 50 and km divided by r.
I'm busy.
Now, when you do this question, use the basic formula which is this. Sometimes you will find a shortcut formula which says V1 plus V2 upon 2. Don't use it. Not recommended. It can lead you into trouble. In many problems it can lead you into trouble. Sometimes it works, sometimes it does not work. This will always work. So you should find total distance and divide that by total time. Now they have not given distances, so maybe you can take, let's say this is home, this is school. You can take the distance to be S. Distance will be the same for the two going, coming, S and S only. Time you can take T1 and T2. So for going to school, the equation would be 30 equal to S by T1. I am giving you the hint basically. This will be the assignment question. For going to the school, it will be 30 equal to S by T1. Likewise, while coming back from the school, it would be, now that I won't tell in totality, something upon something. These two equations, and then you will say for the whole journey of going and coming back, the average speed is total distance, which is S plus S. Total is this S plus this S, 2S, divided by the total time T1 plus T2. That's the correct way to do this problem. Any clarification if you have, then let me know.
Should we fill in the numbers there, or we have to just find the find the average speed?
You have to find just the average speed. I'm interested only in average speed. When you enter the class, you should check the audio wizard to make sure that your volume settings are proper. When you enter the class, that's the first thing you should do. Okay, any other clarification? Fine. So this is your assignment. We stop now.